everyone, so we just finished talking about how to add numbers that have radicals in them. Now we're going to take it one step further and talk about multiplying with radicals. There's three steps that you typically want to follow. So let's look at a scenario like this. So we have 3 rad 12 times 5 rad 3. Now before we even do anything, just like always, we kind of want to simplify this. This makes our lives easier down the road. So we can split up that 12 into 4 times 3. Radical 4 is a perfect square, which is 2. So multiplying that 2 by 3, we get 6 rad 3 times 5 rad 3. So this is my new set. Now, if you didn't want to do that, that's fine. It's just that sometimes when you multiply with bigger numbers, it can get a little messy. So from here, what we want to do is now multiply the coefficients. So we have a 6 and a 5 in front of both these radicals. So we're going to multiply 6 and 5, and we end up getting 30. And then later on, we're going to end up multiplying the rad 3 and rad 3. Step 2 is we're going to take these radicands, the two rad 3's, and multiply them. And now they're going to be underneath the same radical. Whenever you have radicals being multiplied, or as we'll see later on, divided, we can put them together under the same radical. So here we have radical 3 times 3, which is radical 9. Now we have to simplify the radicals. Well, 9 is a perfect square, so that just becomes 3. Then we get 30 times 3, which is 90. Now, if the radical wasn't ended up not being a perfect square, that's fine. We just simplify it like we did before. All right, and that's basically it. So here are the first two questions. Pause the video, work itself, and we'll go over a second. Okay, so well, what we're going to do is we're going to first simplify the 20, since 20 and 80 are fairly big. Kind of want to deal with smaller numbers. Unfortunately, 85 doesn't have any perfect squares for now, so we have this rad 4 times 5. Square root of 4 is 2, so I can multiply the negative 10 to get negative 20. Then from here, we do our first step where we multiply the coefficients. So negative 20x times 6x. And then later on, we're going to multiply those two radicals. Negative 20 times 6 gives us negative 120x squared. And then what we can do is multiply the 5 and the 85 to get radical 425. From here, we're going to have to break up the 425 into a perfect square. So we're going to have to try to simplify this. So that breaks up into radical 25 times 17. 25 is a perfect square. Square root of 25 is 5. So we end up getting negative 120x squared times 5 rad 17. All this together gets us negative 600x squared radical 17. All right. For number 2, we pretty much do the same thing. We're going to start off with simplifying and breaking up the 60 into 4 times 15. Then what we're going to do, this is going to end up being 2. So square root of 4 is 2. And we're going to multiply it with both the 5 over 6 and the 3 over 8. So we have 5 divided by 6 times 2 times 3 over 8. And then we're going to end up having radical 15 times radical 15. So when we multiply all these together, 5 times 2 times 3 divided by 6 times 8, we get 30 over 48. We can simplify that to be 5 over 8. And also, and this is going to help out a lot, radical 15 times radical 15 is going to end up giving you 15, because this is pretty much getting rid of the square root when you multiply two identical roots by itself. So this ends up being 5 over 8 divided by 15, which gets us 75 over 8. And that's pretty much it. Here's the next set. So pause the video, work itself, and we'll go over in a second. All right. First thing that we're going to do is, just like we would with regular numbers, we'll distribute this 3 rad 2 to both terms. So we have 3 rad 2 times 5 rad 2 and 3 rad 2 times 7 rad 6. From here, we do what we did before, where we multiply the coefficients and multiply the radicands. So 3 times 5 is 15, 3 times 7 is 21. Then we're going to end up having rad 2 times rad 2 and rad 2 times rad 6. Now rad 2 times rad 2 is easy enough. That's going to end up getting us rad 4, rad 2 times 6 is rad 12. The radical 12 can be broken up into a 4 times 3. So 4 is the perfect square. For both of these, that just means that I'm going to end up multiplying the coefficients by 2. So this ends up being 15 times 2, and this is going to be 21 times 2. And then there's still going to be this radical 3 left over. Simplifying it, we get 30 plus 42 rad 3. All right. Now for this, say again, just like we did within the polynomial unit, we're going to distribute again, but we're going to have to make sure that we distribute all the terms. So we do 2 times 4, 2 times 3 rad 3, and then we also distribute this negative rad 3. So we do minus 4 times rad 3 and minus 3 times rad 3 times rad 3. So we get this entire string. Going through all the math, 2 times 4 is 8, 2 times 3 rad 3 is 6, negative 4, that multiply rad 3 is just by itself, and then we end up getting 3 rad 3 times rad 3, which will get us rad 9. Doing the math for this, so these are like terms because they both have a radical 3 in them, so we can add their coefficients, or in this case subtract. So 6 minus 4 is 2. And then this is just radical 9 is just 3 because that's a perfect square. So we end up getting 3 times 3. When we simplify all this, we'll end up getting 2 radical 3 minus 1 because this ends up being 8 minus 9, which gets us that minus 1. Right, and here's the last set. Pause the video, work itself. We'll go over in a second. All right. So from here, what we do is we're not going to distribute the square to each terms. That's not what we end up doing. What we do is just copy this twice and just multiply and distribute. So we're basically doing this, 6 plus rad 5 times 6 plus rad 5. That's what it means when we square. Do not distribute because you'll get a different answer. So from here, we distribute each of the terms. We get 6 times 6, 6 times rad 5, 6 times rad 5, and then 5 times rad 5. 6 times 6 is 36. This just adds up because they're like terms to be 12 rad 5. And then radical 5 times radical 5 is just 5. So doing all this and simplifying, we get 41 plus 12 rad 5. And then the last one, same thing as before, we're going to distribute. This time, because of the signs, we end up having plus 2 rad 28 minus 2 rad 28. These are going to end up canceling each other out. So we end up having 2 times 2, which is 4, and rad 28 times rad 28, which is minus 28. Simplifying this gets us negative 24. Now this specific term actually has a very special name. It's called a conjugate pair. We haven't said that word at all this class, but a conjugate pair is referring to a binomial where the expression is identical except for the fact of the symbol, the sign, or whatever operation between them is being the opposite. So if instead of adding two numbers, you're subtracting. So for example, the expression we just dealt with, 2 minus rad 28, 2 plus rad 28, those are conjugate pairs because the only difference is this mathematical operation, the sign. Instead of a minus, it's a plus. This is also another conjugate pair, again, completely identical, but the sign is different. It doesn't even have to have a radical in it. It could be something like this, 3x plus 1, 3x minus 1. In fact, if you recall when we did dots, the difference of two squares, when we factored that using that method, we basically created conjugate pairs. When we took the square root of both terms, the first and last term, and we just put it in a plus b, a minus b form, that was putting in conjugate pairs. So if you see conjugate pairs in this specific unit, what that means is that the terms should end up kind of combining together in a little bit more simplified way. All right. That's pretty much it. If you have any questions, feel free to let me know. Otherwise, I'll see you later. Good luck and have a great day.